Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on algebra, solving systems of two linear equations. So if you are given a set of equations and you're asked to solve, so you're asked to solve the following set of equations. So if you're asked to solve for x and y, or just asked to solve, so first thing you want to do is see if there's something you can eliminate and by adding or subtracting. So right off the bat, when I look at this example, I see that I have a negative y and positive y. So if I added these, those two would just cancel each other out, and I would end up with 4x equals 4. And if I divided both sides of this part by 4, I would just end up with x equals 1. And then once I have the value for x, I can substitute that into either equation to figure out what y equals. So I'm going to pick the second equation because it's a little bit simpler than the first. So I'm going to plug in 1 plus y equals 3, and then when you bring this over here, it becomes y equals 3 minus 1, which is equal to 2. Okay, so the solution to this set of equations is 1, 2. Okay, so we can try a few other examples. Say we're asked to solve the following. So in this case, you want to make either the x's or the y's the same value, and then try to eliminate one of them, just like before. Now in this case, when we look at this one, we don't have two equal values, but if I multiply, say, the first equation by, so if I want to just eliminate the y's again, I can do that, or I can eliminate the x's. I'm just going to go ahead and eliminate the y's. So what I'm going to do is I'm going to multiply the first equation by 4. And when I do that, I'm going to get, so I'm going to multiply everything by 4. Then I'm going to multiply the second equation, everything by 3. So when I do that, I get 21x plus 12y equals 6. And then I'm going to add them. You can probably see why I picked these numbers to make the y values the same. So over here I end up with 12y and 12y. One's negative and one's positive, so therefore I'm going to add. If they were both positive, I would have subtracted the equations to eliminate the y. So because they're negative, one's negative, one's positive, the thing to do is add, but you can solve these by adding or subtracting. Okay, so we're going to go ahead and add them, and then when we do that, we get 41x is equal to 82. And then dividing both sides of that equation by 41, we get x is equal to 2. Then once we have that, we can substitute that into either equation. I'm just going to pick equation 1, the first one. So 5 times 2 minus 3y is equal to 19. So then we get 10 minus 3y is equal to 19. And then, okay, so we're going to bring the 19 over here and the number over here, so it becomes 10 minus 19 is equal to positive 3y. So negative 9 is equal to 3y, and y is equal to negative 3 is our final answer. So our solution is 2, negative 3. Okay, so that's our final solution to that system of equations. So this is a method of adding and subtracting to solve a system of two equations. But we can also, there's another method that's used to solve a system of equations, and that method is by substitution. So I'm going to show you the substitution method also. So the first one I showed you was the addition-subtraction method. So I'm just going to go back here. So the method I showed you here was addition / or subtraction method, depending on whichever one is required. So here we're going to do substitution. So again, we're going to solve the following. 7x minus 9y is equal to 1. The easiest method is addition and subtraction, but there are other ways to solve these. So if we're given this system of equations, So you could have been given the equation in this form also. So it could have been 5x plus y is equal to negative 17. So, and then you would have brought the 5 over to the other side. So what you're going to do here is you're going to substitute one of the equations into the other, and then you're going to solve. So what I'm going to do is, so here's equation 1 and here's equation 2. I'm going to substitute equation 2 into equation 1. So that's just going to be, so basically, so 2, I already have 2 written in terms of y. If it wasn't, I would have isolated for x or y, and then I would have substituted it into the other equation. So here it's already written in terms of y in the question, but if this, you know, the x was on this side, and the number was on this side, I would have just brought the x over, and then I would have written as y, and now I can substitute this y value into this equation. So I substitute that into equation 2 into equation 1. And then as you notice, now I've got an equation only in terms of x. So I'm just bringing this in. This becomes a plus because we have 2 negatives. And then these are like terms, so you would go ahead and add them. You can bring the number over to the other side. So 1 minus 153 becomes minus 152. And then divide both sides of the equation by negative 38, and you get x equals 4. Okay, so as you can see, we just solved for x by doing this. Okay, and then once you solve for x, you substitute that value either into equation 1 or 2, doesn't matter which one. I'm going to just pick 2 because it's already written in terms of y, because I'm trying to look for y. So then you plug that in, minus 17. 20 minus 17 equals to 3. So the solution to this system of equations is 4, 3. Okay, and that's solving by substitution. And sometimes you might notice that a system of equation does not have a solution. So for example, you could be given something like the following: solve the system of equations. 2x plus 3y is equal to 5. 6x plus 9y is equal to 2. So here, if I want to solve this one by the addition subtraction method, what I could do is multiply the first equation by 3, and the second one I would just keep as is, and then I would use subtraction to eliminate the y's. So if I multiply the first one by 3, and this one just stays as it is, I'm going to get 6x plus 9y is equal to 15. And then this one here is 6x plus 9y is equal to 2. I'm going to use subtraction to eliminate the y's, but in this case what happens is the x's also get eliminated. So you end up with 0x plus 0y is equal to a number, and this is not possible. 0, this is going to just become 0 is equal to 13, which is not correct. So this is no solution because it's not possible to have this. So if you end up in a situation like that, that means that this system of equations that you're given does not actually have a solution. Okay? Now you could be given systems of equations where you have fractions, like for example, solve this system of equations, x over 2 plus y over 3 is equal to 5 over 6, and x over 4 minus y over 2 is equal to 7 over 4. So right off the bat, what you want to do is eliminate your lowest, you want to eliminate your fractions. So you're going to multiply each equation by their lowest common denominator. So the lowest common denominator, the smallest number that all of these divide into, is the number 6. And over here, the lowest common denominator, the smallest number that all of the bottom numbers divide into, is the number 4. So what I'm going to do is I'm going to multiply the first equation by 6. When I do that, what happens is I end up with 3x plus 2y equaling to 5. That's the first one. And then over here, if we multiply this one by 4, this is minus y over 2 equals 7 over 4. Multiply by 4, we get x minus 2y equals 7. Okay, so now we've just got a regular system of equations. So when you have fractions, you want to eliminate them and then just solve the system of equations from there. So here we've got now a general system of equations, and in this case we could just go ahead and add, and that would eliminate the y's, and we would get 4x is equal to 12, and then x equals 3. And then we would plug that into one of our newer equations without the fractions. We could plug it into here too, but I would prefer this, it's easier here. So we can plug it into, say, the first equation, x equals 3. So when we do that, we would get 3 times 3 plus 2y equals 5, 9 plus 2y equals 5, 2y equals 5 minus 9, which is negative 4, y equals negative 2. So the solution would be 3, negative 2. Okay? So that would be the solution for this one. So let's try another example. Okay, over here we okay, let's see here. Now I'm just trying to see if, okay, so here we've got something a little bit different. Now this one is actually non-linear, so I am going to save this for the next lesson because it's not linear, so we'll just save that for another lesson. Okay. Alright, yeah, so that one there that I just showed you was a non-linear equation. So I will post that in the next